Welcome back, everybody. We are going to do a couple more problems in 8.3. This will be 8.3B with some more problems. And then we'll dive into 8.4, which is on vectors, algebra with vectors. So one of them, let's say we have a force of 16 pounds is required to hold a lawnmower on an incline. And we'll say it's a 40-pound lawnmower. And it's holding it stationary on an incline. A parking brake for a lawnmower. Find the angle of incline. So, let's draw a picture. Okay, Matt. There you go. We got a lawnmower, push mower. Some little blades on it down below. And it's not moving. Gravity is pushing it that way. Well. Effectively, gravity is straight down. So we got 40 pounds. Maybe I'll make it shorter like that. We'll say it's 40 pounds going downward. We are looking for this angle right here. So it wants to move that direction. But we have a force, something's holding it that way. That's 16 pounds. And that's keeping it from moving. Try to do it a little bit differently, give myself a little bit more room. My lawnmower is right here. We got our 16 that way. We have our 40 going downward this way. And maybe instead of making it like that, I'm gonna go like that. We're gonna have these two lines parallel. So that'll make a right angle. If I do that, this angle I'm looking for here by the alternate interior angles thing, this is, that line is the transversal line for two parallel lines makes this theta the same as that theta. And we could see that by doing this as 90 minus theta here. Because that makes a right triangle. And then this angle has to be added at 90 as well, so we can see that's theta as well. You don't have to just take my word for it from alternating interior angles. We can see it from there. So 90 minus theta is that, but this whole thing is a right angle now. So that's kind of like this is the 16 going right there. Because they're pointing in the same direction. And if I look at that triangle, rotate it like this was my 16 going like that. theta's there. And that was 40 pounds like that. So if I don't know, it's a little easier for me to look at a triangle when I make it flat, I don't know why. If you're good with this triangle, you don't need to redraw it. I think it's a little easier for me to see that this is opposite and hypotenuse, opposite and hypotenuse is sine. So 16 pounds of force over 40 pounds of force. What is that? 0.4? 4 reduces to 4/10. Yeah, 0.4. So sine theta equals 0.4. So theta is gonna equal sine inverse of 0.4. And I'm getting 23.6 degrees if I just round to 1 decimal place. Which makes it a pretty steep incline. It takes practice to figure out how to draw the right triangle on these. There's all sorts of triangles you can draw on this, what's wrong?
I'm not following the triangle thing, that's all.
Which part? Where did I lose you?
I think you lost me where theta is, how do we get to the like inner theta there underneath the triangle?
That theta?
Yeah,
Alright, so. This is theta here. This triangle. Has a right triangle there. Which means that this angle right here. Has to be 90 minus theta,
okay,
okay? And now, looking at a different triangle. If I look at a triangle like this. This is making a right, I don't even need to look at it as a triangle. Just make it a right angle there. And a right angle has to add the 90. So if I don't know what this angle is here, I'll call it A. 90 minus theta plus A has to add the 90.
okay,
You're gonna see A equals theta.
okay. Okay,
It's also when you have. Something like this, we talk about like alternate interior angles. Are the same. I thought we talked about that. Well, those are my two parallel lines right there. I don't know how that's gonna help with the alternate interior. That would make this angle. Angle theta. Shit. You kinda have to do the triangles.
no, the triangle makes sense.
That's not helping. In my head, it was helping.
Because the theta, so the theta on the bottom, would be where the second 16 is written. That theta is the same as our first theta,
Yeah, if I put a theta right there,
that's the same as the first, and so that theta. Is also. So that theta kind of adds up to the. But like you said, yeah, it adds up to be the other half of the other portion of the 90 that is needed to make the triangle, so that would also mean.
that's another way you could go about getting it, yeah.
Yeah, that would mean that it's that.
Like I said, it takes some practice, you gotta start drawing a bunch of triangles and figuring out. Eventually you start recognizing, you get comfortable with recognizing that this is gonna make a right angle. And with practice, you get used to going, okay, that's theta and that's theta. But that's just from experience, practice. Taking the time to do it like that helps. Where else does this kind of stuff come in? Airplane, does anyone need that up longer? Okay. Airplanes flying. There's something called the airspeed. Which is speed relative to the air. And wind speed. Which is obviously speed of the wind. So this is like how the plane is moving. Plane's path. This is the wind's path. Or vector. And ground speed. Is speed or relative to the earth. Or to the ground. And this is the combined path. Of the plane under influence of wind. Pictorially, if the plane is flying this way. That's our airspeed. But the wind is blowing this way. The actual path. Will be the sum of those vectors. Actual path. And speed. Which will be A plus W. Yeah,
Speed is velocity. in this calculation.
speed is the magnitude of velocity here. Speed is just a number, as is magnitude, but velocity is speed with direction. So it's like the how fast it's going, but not necessarily what direction it's going. I think this makes kind of sense. You're flying that way, but the wind's blowing you off course, where do you actually end up? Happens all the time.
It's not on the screen or something? Over to AW.
Help?
Yeah. Actual path is ground speed.
Yeah, the actual path is the ground speed, which is the path that like relative, if you, where your shadow's going. If the sun was straight above you, kind of thing. Like if you were to all of a sudden land, where would you actually land? You might have been flowing north, but the wind was blowing you eastward. So you're not gonna land directly north of where you were unless you compensate for it. You have to choose your airspeed vector. To compensate with the wind speed to get to your target destination. That's what pilots used to have to do. Now the computer does it for them. But it's like running with a kite. The kite follows you, but if the wind's blowing, the kite's blowing off the bucket side. Alright, so let's give an example here. A plane flies out of bearing. Of 239 degrees. With an airspeed 425 miles per hour. The wind is blowing in. From. North 65 degrees west. At a speed of 36 miles an hour. Find the resultant bearing and speed. So bearing is off of true north clockwise. So bearing, the plane bearing, I'll do in red. It's 239 degrees this way, that would be 180. That's kind of like 239. And we'll make it a longer vector because it's kind of long. 425 is a pretty big speed. And I deliberately wrote them in different notations because they pop up all the time in different ways. So bearing is clockwise off of north. But then like when they do north by west or north by east or something. They're telling you the first letter starts what directions go. And then rotate which direction, how many degrees. So in this case, I'm gonna rotate 65 degrees that way. In the west direction. Oh. I'm gonna make this a lot shorter. This is a short vector because it's only 36 compared to 36 miles per hour. And this was 65 degrees. So what I'm gonna do is we're looking for the ground speed vector, which is gonna add these two together. So I'm gonna move this kind of like do a tip to tail thing here. And sketch this like this. That's like our 36 as well. And this is our ground speed vector. So I have this long triangle here. And I need to figure out what angles go inside of it. That's got a length of 36, that's got a length of 425 or speed. This is the ground speed we're looking for. If I can find this angle right there, I can use law of cosines. To find G. So we kind of need to find this, what is this? So let's reason out what we have here. If this is 239. Then this part right here. Has to be 31. Because 239 plus 31 will add to 270. That's not entirely what I need. But we're getting somewhere. If I make a little vertical line, I think this is gonna help if I have a vertical line through here. Maybe I'll do it like this to help show that I'm just using for references here. If that's 31 degrees. Then this is 31 degrees also by the alternate interior. If I can find. This angle, I could calculate this. And I can't. This angle right here, question mark angle right here. By alternate interior angles is gonna be the same as that angle right there. Cause this will be 65 degrees also. I've just moved that wind speed vector down here. So it's still gotta be 65 north, 65 degrees west. Does that make sense? I just kind of moved this vector down here to do the tip to tail. It's still gotta be north 65 degrees west, so if I did the line, that's north. 65 degrees west is that. These two have to add to 90. So this has gotta be 25 degrees. Which means I've got 25 degrees here. 31 degrees here. This is a semicircle, which is 180 degrees. So 25 degrees plus theta plus 31 has to equal that 180. Yeah, looks like 124. So no, this would have been really hard if I didn't add in this. Line right here to like help calculate angles. Sometimes these problems take some fucking thinking. Not just what are my formulas and use them, like play with the image a little bit until you find what you need. But now I can use law of cosines. I'll have g squared, this is like a, b, c. C squared equals a squared plus b squared. Minus 2ab cosine theta. I have g squared equals 36 squared. Plus 425 squared. Minus 2 times 36 times 425. Times cosine of 124 degrees. And that is just a bunch of calculator work. And this is really the magnitude of g squared. And I'm getting magnitude of g squared is a high number. Unless I fuck this up. Plus some change. And then I gotta take the square root of that. And I'm getting g is approximately 446, that was the magnitude of g. 446 miles per hour. We wanted the bearing also. The bearing is off of this one, 239. Plus whatever this angle is. So bearing will be. The 239 degrees. Plus like the beta I have in this picture. But now that we've got theta. And we've got all our sides, we can use the law of sines. So we'll say sine beta. Over 36. Equals sine 124. Over 446. Sine inverse of that, I'm getting beta is approximately 3.8 degrees. So our bearing will be 239 plus 3.8 is approximately 242.8 degrees. Complicated shit, right? I know. Just imagine the pilot had to do that shit in the air to figure out this shit. Like being a pilot, you used to have to be really smart. Now you just need to like practice in a flight simulator.
That's all.
The plane does all this, most of the shit. You need to know how to, you know. Compensate for it, but all the heading and everything is gonna be calculated by either people on the ground. Or like people that are not actively flying the plane. But when we first started flying, there was no fucking flight towers. You know, the Wright brothers and shit like that, right after them. There was no flight towers, there was no one on ground telling you which way to fly, if you wanted to fucking end somewhere and the wind's blowing you off course. Good shit, alright, anyone need this longer? Alright. So I'm gonna stop the video there and start a new one.